Machine learning and AI has been on the rise recently, but there's a flaw in the way the machine learning models are being trained right now. Today, let us introduce you to a new way of performing machine learning that's gaining popularity in the industry. Let's discuss how federated learning differs from traditional methods, its advantages, architecture, and the challenges that come with it. But first, a quick recap of the traditional method of machine learning. In traditional machine learning, we collect data from various sources and send it to a central server, where machine learning algorithm processes and analyzes the data. This method is great for generating accurate predictions and insights, but it comes with some limitations, particularly when it comes to privacy. As you might know, when we collect data from different sources, some of that data might be sensitive or private. Think about your personal information, such as your name, address, or even your search history. This data is private and should not be shared with anyone else without your consent. However, when we send data to a central server for analysis, there's always a risk that someone might access it without authorization. What if the data could stay on the device where it was collected and only the updates to the machine learning model were sent to the central server? This way, your private data would remain on your device and no one else could access it. This is where federated learning comes in. Federated learning is a new approach to machine learning that allows us to process and analyze data without sending it to a central server. So now Bob's data can stay on his iPhone, John's on his iPad, and Adam's on his Mac, while also the server gets updated and trained.
Now, I will provide a short glimpse on the key differences between federated learning and traditional machine learning. In traditional machine learning, data is typically collected and stored centrally in a single location. That is, it involves a centralized server, which is used to train a model. It needs to collect data from multiple sources, which requires large computing power. Federated learning, on the other hand, is a decentralized approach. That is, it distributes the training data across multiple entities. Each entity retains control of their data, and the model is trained on local devices, with only the model parameters being shared among the devices. This approach is useful in situations where data privacy is a concern, or data or where data is distributed across different locations, allowing for flexibility also. Now, talking about in simple terms, let me give you an example. Imagine you need to create a presentation with your classmates. In traditional machine learning, everyone would work on the presentation together at the same time, all looking at the same computer and contributing equally to the work. But in federated learning, things work a bit differently. Each person in the group has their own computer and they each work on different parts of the presentation. Then, instead of coming together and combining their work on the computer, each person sends their work to a central coordinator who combines all of the different parts into one complete presentation.
So I'm here to talk about the advantages of federated learning. So to list them out, you can see increased privacy. In terms of privacy, federated learning allows for the training of machine learning models on decentralized data sources, enabling data privacy while still allowing for collaborative learning. Improved scalability. Federated learning allows for the use of large datasets that are distributed across multiple devices, enabling the scaling of machine learning models to a larger and more complex datasets. When we talk about flexibility, federated learning enables the training of machine learning models on a heterogeneous data source, allowing for the inclusion of data from different kinds of devices and locations. This obviously makes the data model more flexible. Now we talk about the latency. It actually reduces the latency because it enables the processing of data locally, reducing the amount of data that needs to be transferred from a central location. So when the transfer is less, obviously the latency is reduced, and it eventually improves the overall performance of the system. Now, when we talk about the cost, federated learning can reduce the cost of machine learning by reducing the need for central data storage and transfer. And when the need for these machines are not there, obviously the cost is to go down, as well as need for powerful computing infrastructures as well, because again, it is a decentralized form of learning. Now, if we are to talk about robustness, federated learning can improve the robustness of the machine learning models by training them on a diverse set of data sources. As much as the data is diverse, the chances that the model is biased or there is noise in training data is reduced. And this ultimately improves the robustness of the system.
Have you ever wondered how multiple entities can collaborate to train a shared model without compromising their data privacy? Well, that's where federated learning comes in with its innovative architecture. Let's start with the client device, which is like the heart of the federated learning architecture. These devices, such as mobile phones and laptop, performs local model training using their respective datasets, ensuring that the data remains private and entities retain control over their data. It's like having your own personal trainer for your data. Next, the server in federated learning is responsible for coordinating the entire training process. It receives local model updates from the client devices, aggregates them, and generates a new global model. One crucial feature of the server is that it does not have access to the raw data. This ensures that the privacy of the data on the client device is always maintained. Instead, the server only receives update from the to the model parameters from each devices. The server's role is like similar to the central hub. It receives information from each devices and processes it and sends back an updated global model to each device. Communication protocol is responsible for ensuring that the client device and the server communicate effectively and securely. We can think it of like a language translator in a room who ensures that everyone understands each other. The communication protocol specifies the information that the client device sends to the server and updates that the server sends to the client. It must be carefully designed to maintain balance of communication overhead with the accuracy and privacy requirements of the model. Next component is model updates. During each round of federated learning, each client device trains a local model using its data and computes a model update. The model update contains information about the changes made to the model weights based on the local data. Once the local Once the model updates are generated, they are sent to the server for the aggregation and generation of new global model. Aggregation algorithm. The aggregation component plays a critical role in generating a new global model by combining the model updates received from the client devices. To do this, the server employs an aggregation algorithm which determines the mathematical operation used to merge updates, and it can be like simple or a complex one that takes into account the performance of each devices to weight their contributions. Therefore, a well designed and well written aggregation algorithm can significantly improve performance and efficiency of the federated learning system. Lastly, global model. The global model is generated by the server through the aggregation of model updates received from the client devices. It is the weighted average of model updates with the weights determined by the aggregation algorithm. This model, global model, is then sent back to the client devices, which uses it as a starting point for the next round of a local training. Now, as a programmer, understanding the basic concept and architecture of federated learning and its potential application, as mentioned earlier, can help us build better and more secure machine learning models that can be trained on data that is spread across multiple devices and entities while maintaining the privacy of data on each devices.
So, in conclusion, federated learning is a promising approach that has gained a lot of attention in recent years. Its unique architecture allows for decentralized model training without compromising data privacy. By leveraging the power of distributed computing, federated learning can achieve high accuracy in a wide range of applications. One of the key advantages of federated learning is its ability to handle large volumes of data that would otherwise be impossible to transfer to a centralized server. Additionally, federated learning reduces the risk of data breaches, ensuring data privacy and security. This can be particularly important in industries such as healthcare, where sensitive data must be protected. The architecture of federated learning includes the client side, server side, communication protocol, modal updates, and aggregation algorithm. Each layer plays a critical role in ensuring the success of federated learning, and any improvement made to one layer can significantly impact the overall performance. Overall, federated learning is a promising technology that is rapidly gaining popularity. Talking about the challenges, one significant issue is that data on each device may be non IID. independent and identically distributed, meaning that it may be difficult to ensure that the models trained on each device are consistent. Additionally, there may be issues with device heterogeneity as different devices may be different hardware and software configurations that can affect model performance. As we continue to explore its full potential, it is important to keep in mind the ethical and legal considerations surrounding data privacy and security. By doing so, we can ensure that federated learning remains a valuable and sustainable approach to machine learning. Thank you so much.